Thank you for joining this lesson. We're going to discuss defects of vision, or rather disorders of the human eye. Remember to subscribe to this channel and to also share the link with friends. The first defect of the human eye is what we call myopia. That is the scientific name, and this is called the short sight or short-sightedness. Now, when an individual has these defects, images of near objects, it's good we mention that, images of near objects, or rather, rays from a near object. Rays from a near object are clearly focused on the retina, and that makes the person to see a clear image of the object which is near. But or while rays from a far object are focused before the retina, hence the image appearing to be blurred. I must mention that the retina is like the screen where images form in the human eye. Then there is a lens which focuses, or rather which refracts light so that it may be focused at the retina. Let me show you the defect. Normally, the human eye of an individual who has short sight, let me draw it. This is a lens of the eye. Then now this is the eye, the eyeball. And at the back is where we're calling the retina. So the part here is called the retina, the part here at the back. That is the retina of the eye. That is where images form. So if an object is near, say for example at a point here, this is a near object. Now we will have rays moving from such a near object to the eye or to the eye lens. Let me draw some rays now. That ray, then another ray on the other side. We will have these rays now being focused exactly at the retina from a near object. So that a clear image is formed. So at the retina now, we are talking of rays converging and forming a very clear image. This is now a short-sighted person. But if rays are from a far object, let me now draw that. If rays are from a far object or a distant object, we will have the same person not being able to see, because rays from a distant object will come parallel and close to the lens. So a ray will come parallel to that, then another one be coming like this. These rays now, instead of being focused at the retina for a clear image, they are going to meet before the retina, and we are going to see the possible causes or reasons why which might lead to such a defect. So you can see now, rays from a distant object, when they hit the lens of the eye, instead of being focused at the retina, they are being focused before the retina, and the image appears blurred, such a human eye cannot see. There are some possible causes of this. This might be caused by what we call, let me write the causes of myopia, or possible causes of myopia. Possible causes of myopia, short sight. One is what we call a long eyeball. Eyeball now is like generally the diameter of the eye from the lens, from the eye lens, to where the retina is. Now this is being called the eyeball of the eye. So if the eyeball is too long, then the rays will intersect. This distance now is the eyeball. Generally, the whole of that distance, if it's too long, then the rays might intersect before reaching the retina. That is a possible cause of such a defect. Number two, we might have what we call a short focal length. A short focal length of the eye lens. Now, the eye is having a converging lens. And if this lens is having a short focal length, then the eye will have a very high power. The power of an eye is the power of a lens is what we call its refractive ability. So remember, power of a lens is given by the reciprocal of the focal length. So that means the greater the focal length, the lesser the power, or the less the power. Now, the shorter the focal length, the greater the resulting power. Therefore, if the focal length of the eye lens is too short, such an eye will have a very high refractive ability, and it will make rays converge too early because the refractive ability is high. That way, it will lead to myopia. There is how we can correct this defect. Myopia or short sight is corrected using the diverging lens. The diverging, write it well, the diverging lens. When you go to a clinical officer suffering from myopia, she will recommend glasses or goggles which are made of a diverging lens. Let me show you how the lens will be used to correct such a defect. This is the eye lens. This is the eyeball. Then we are having the retina pointed at this. So now rays from a distant object, if they come to the lens, now they will be finding a diverging lens. So we will have a diverging lens because we are having the glasses which are made of a diverging lens. So this is the diverging lens. Diverging lens. Now when rays come now parallel to the principal axis of the lens, because they are from a distant object, I'll show you what will happen. Now the rays are coming, another one from the lower side. This is a ray parallel to another one. These rays now, once they hit the lens, because it is a diverging lens, the rays are going to be diverged by the lens, and they will appear to be coming from its principal focus. So you find that now the ray has to be refracted away, but in a way that it's coming from its principal focus, the principal focus of the lens now that you've used. So the ray will be diverged, but such a way that it is originating from a point just in front of the lens. Therefore, the rays now will appear to be coming from somewhere near. So the object will appear to have been brought closer because of the diverging, which is happening such that the rays are from a principal focus just in front of the lens. And now the eye will be able to focus these rays. Because now they appear to be coming from a near object, now they will get focused perfectly at the retina, and the individual will be able to see clearly. So now the rays will go exactly to a point at the retina. So now the defect has been corrected using a diverging lens.